The future of earthquake-resilient foundations. Welcome back to Blueprint to Reality, where we turn complex engineering principles into simple, powerful stories you can understand. Today, we explore one of the most important topics in structural design, how the foundations of tomorrow will stand strong against the earthquakes of the future. Introduction. Every earthquake begins underground, and so does every building's fight for survival. While engineers have spent decades strengthening columns, beams, and walls, it is the foundation that truly determines whether a structure stands or fails. As seismic risks grow and cities expand, engineers are developing groundbreaking technologies to create earthquake-resilient foundations that can protect millions of lives. In this video, we look at the innovations shaping the future of foundation design. 1. Smarter soil structure interaction, the next frontier. The future of resilient foundations begins with understanding the relationship between the soil and the structure. Instead of designing buildings alone, engineers are now designing systems where the soil, the foundation, and the superstructure communicate and work together. Key advancements include high-precision geotechnical modeling, real-time soil behavior monitoring, improved seismic microzonation, maps, AI-powered predictions of soil response. These tools help engineers create foundations that adapt to local soil conditions more accurately than ever before. 2. Base isolation, becoming more affordable and widely used. Base isolation isn't new, but the future will see it used far more commonly, even in smaller buildings. By placing flexible bearings between the foundation and the building, base isolation allows structures to move independently of ground shaking, reducing forces by up to 80%. Emerging trends. Cheaper high-performance rubber bearing sliding isolation systems for heavy structures, low-maintenance isolators for residential use, smart isolators that adjust stiffness during earthquakes. This technology is becoming the backbone of next-generation seismic design. 3. Energy-dissipating foundations, turning earthquakes into manageable force. New foundation systems focus on controlling how energy enters the structure. Instead of resisting all seismic force, these systems absorb, redirect, or dissipate it. Examples include foundation dampers, replaceable steel fuses, buckling restrained systems at the base, viscoelastic layers beneath footings. These innovations reduce structural stress and prevent catastrophic collapses during strong earthquakes. 4. Deep foundations reinvented, stronger, smarter, and cleaner. Piles and drilled shaft have always been essential for unstable soils, but the future brings major improvements. Future trends. High-strength composite piles, smart piles with embedded sensors, energy-efficient installation methods, hybrid pile systems combining steel, concrete, and polymers. These advancements allow foundations to stay stable even in liquefiable soil or regions with extreme shaking. 5. Foundations that resist liquefaction. Liquefaction remains one of the deadliest threats to foundations. Future earthquake-resilient designs focus on preventing or reducing liquefaction. New solutions include deep soil mixing with cementitious materials, ground densification, using modern vibro techniques, drain foundations, using gravel, stone columns, or geosynthetics, chemical grouting, with environmentally friendly stabilizers. These technologies ensure the soil maintains strength when shaking begins. 6. 3D printed and modular foundations. As construction speeds increase, the world is moving toward fast, precise, and eco-friendly foundation systems. Advantages of future modular foundations. Rapid installation, consistent quality, lower labor, cost reduced, environmental impact. 3D printed foundation components, when combined with seismic-resistant designs, could revolutionize how quickly safe structures are built in earthquake-prone regions. 7. Smart foundations with real-time monitoring. Foundations of the future will not be silent. They will be equipped with sensors that collect data on moisture, vibration, stress, and settlement. What smart foundations can do: detect early foundation problems, monitor soil pressure changes, send alerts during strong shaking, help engineers evaluate building health after earthquakes. This turns foundations into active safety systems, not passive structures. 8. The role of AI and machine learning in future designs. AI is transforming every engineering discipline, including earthquake-resistant design. AI can Predict how foundations will behave under different earthquakes, optimize footing size and material use, evaluate millions of soil structure scenarios in seconds, reduce human error in design. This ensures safer, more cost-efficient foundations customized at each location. Conclusion: the future of earthquake-resilient foundations is smarter, faster, and more innovative than anything the world has seen before. From base isolation to smart sensors, from liquefaction-resistant soils to AI-driven predictions, these technologies are building a safer world. Earthquakes are inevitable, but catastrophic failures don't have to be. Foundations are no longer just structural support. They're the first line of defense against nature's most powerful forces. Thank you for watching Blueprint to Reality. If you enjoyed this breakdown of future earthquake-resistant foundation systems, make sure to like, share, and subscribe. Comment below if you want a video on future earthquake-resistant buildings or how soil liquefaction works. See you in the next episode, where we turn complex engineering ideas into real understanding.